So, counting methods review quiz. We'll bring back my favorite student. In fact, we'll even call this answers. There we go. It says show all work, blah, 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 blah. Okay. Multiple choice. At the cafeteria at Pitt Meadow Secondary School, Chef Dueck, has created 4 feature meals, 3 drink specials, and 4 dessert choices. I think this is a fundamental counting principle question because I think I can choose a meal, a drink, and a dessert. How many ways do I have to choose a meal? 4. How many ways do I have to choose a drink? 3. How many ways do I have to choose dessert? 4. Let me say this again. I can choose a meal and a drink and a dessert. In this unit, and means multiply. It's going to be 4 times 3 times 4. B, 48. Number 2, how many different arrangements? This is my trigger word. The word arrangements means permutation of all the letters of Toronto, Ontario. When I'm doing a word, I have to ask, okay, are letters repeating or not? Okay, then I have to use my, there's going to be stuff on the bottom of the fraction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's going to be 14 factorial divided by how many t's? 1, 2, 3 t's. 1, 2, 3, 4, 5 O's, 2 R's, I already did the O's, 2 N's, I already did the T's, I already did the O's, I already did the O's, I already did the N's, I already did the T's, 1 A, meh, I already did the R's, 1 I, meh, okay, there it is, that's what I'm going to type in. So, dope. Menu, run, option, F6, F3, 14 factorial divided by, and I have to tell my calculator I want this all on the bottom, 3 factorial times 5 factorial times 2 times 2. Mr. Dueck, why didn't you put the factorials after the 2? Because I've done this so often that I know 2 factorial is just plain old 2, and I'm lazy. In fact, I could have 3 factorial I know was 6, and 5 factorial I actually know is 120. I've done these so often. Anyways, is the answer 302, that there? Is the answer D? D. Number 3, what value is equivalent by definition to that? By definition, what I mean is this. On your formula sheet, we defined n permutate r as n factorial all over n minus r factorial. So this is going to be 1,000 factorial all over 1,000 take away 4 factorial. B. B. Number 4. How many 3-letter arrangements? Brooke, what's the key word in number 4? Yeah, it tells me it's a permutation. This time they want me to do 3 letters. I can do this 2 ways. I could either go with the fundamental counting principle, and I could say you have 6 letters to pick from, then you have 5 letters to pick from, then you have 4 letters to pick from, or the shortcut was to say from 6 letters, permutate 3. The second one is faster. The first one I can do in my head because it's 30 times 4. The answer is 120. And, oh, okay, I guess none of these. On your test, I'm not going to give you the none of these answers. I'm not a big fan of that. But my friend who created this test for his students was. That's why I turned this into a quiz after a while. I didn't like giving it as a test. Turn the page. That's the key word in this question. That's the key word in this question. I forgot to ask. Was anyone away last week and didn't get the quiz? You're all here, right? Okay. Why is cards the key word? Because cards tells me it's a choose. Is there a dumb way to remember that? Yeah, C and C. But also because I've played cards. I don't care when I get the ace. I only care if I get the ace. I put them in order afterwards just to keep track of them in my hand, but I'm telling you, the order doesn't matter. Now, choose. The next question I ask is, have they taken my group of 52 cards and have they broken it into subgroups? I think in this question they have, because now they're talking about hearts and clubs. Bucket. What's my bucket going to look like? There's going to be 3 groups. Hearts, clubs, and others. How many hearts are there in the deck? Grand total. So how many hearts are there in the bucket? Grand total, 13. How many clubs are in the deck? Grand total, 13. I am going to expect you on your test to know what a deck of cards looks like. I gave you a picture of one in lesson 5, I think, where we looked at applications of combinatorics. 4 suits, 52 cards, 13 in each suit, 26 black, 26 red, 12 face cards, whatever. You need to know what a deck of card looks like, and 26 others. And it looks like I want 3 hearts, 2 clubs, and no others. It's going to be 13 choose 3 and 13 choose 2 and 26 choose 0. Although, what's anything choose 0? Sorry? 1. I wrote it, but I wouldn't type that. I do tend to write it out, though, because I have a bit of a built-in error check. My built-in error check is the front numbers add to 52 cards. The last numbers add to how many I'm picking, 5. From 52 cards, I am picking 5. That's my, to make sure I didn't miss anything, little built-in error check. I find it handy. On my calculator, though, I'm just going to go 13, choose 3, and careful, Mr. Dueck. 13, choose 2. 22,308. Number 6. In Square City, the city's blocks form the shape of a 6x6 square. Uh-oh, I got to draw a picture. I think that's 6x6. It says all the roads run either north, south, or east, west. There's my grid. Torrin starts at the northeast corner and walks to the southwest corner every day. If he walks a different route each day, how long will he have walked all possible routes? Well, it looks like he's going to have to go left, 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 or you could call that west, 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 whatever. And he's going to have to go down, 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 down. The number of different routes, I think, is going to be the number of different routes is going to be 12 factorial divided by 6 factorial times 6 factorial. Probably could have typed 6 factorial squared, because it's, you know what, I don't even know if my calculator will let me do that, and maybe this is a good time to do that as an experiment right now. Oh, but first, hang on, I have a latecomer. I'm just going to see, I don't know if I can do a squared. Oh, it did let me, okay. Who knew? Found something new out. There is a total of 924 paths. Mr. Dueck, I don't see that as an answer. Well, that's not what it said. Then it said, okay, if he walks 1 path each day, how long? I looked at my answers and I noticed most of them were in years. So I said, yeah, I think I'm going to now divide by 365 days per year. And when I did that, I got 2.53. Around 2.5 years, give or take. Okay. That was just a nice twist, applying the pathway. Definitely on your test, you will see 2 pathway problems. One regular, where you can use the permutation shortcut, and one irregular where you have to fall back on Pascal's triangle. In fact, I'll even be more blatant. Are you ready? Are you ready? The regular pathway will probably be on the multiple choice, and the irregular Pascal's will probably be on the written, because you kind of have to write and show work on those anyways. And also, that way I can find where you made your mistake if you did an adding mistake and still give you lots of part marks and stuff like that. Okay? In how many ways? So number 7. This one now is, I just got to think about this. It says, in how many ways can 4 women and 3 men be seated on a bench if the men and women must alternate seats? I looked at this and I said, I'm not sure this is a choose. I don't, huh? My fallback when I run into a roadblock is the fundamental counting principle. My fallback is, if I don't know what to do, I draw a blank. I'm good at drawing a blank. No, I mean, actually. So I said there's 7 people. I drew 1, 2, 3, 4, 5, 6, 7 blanks. That took 2 seconds. And then I started to see it. How many women are there? How many guys are there? If I want to go every other gender, what must I start with? A guy or a girl based on these numbers here? So I said it's got to be... Oh. How many ways do I have to pick the first woman? Then. Oh, and then I said, you know what? This is going to be first man, second man, third man. I said 3, 2, and 1. I said I could multiply all those out, but I actually noticed it ended up being, as a shortcut, that. Yes? Because I did go 4, 3, 2, 1. And so I'm going to type that on my calculator. 4 factorial times 3 factorial. And it looks like there's 144 different ways if we have to alternate. So this was just taking a fundamental counting principle with a restriction. Number 8, what's the 7th term? Okay. I write that down. Then, over somewhere else, I write down the term formula, which is this. Do I have to memorize this? No, it's on your formula sheet. Have I memorized it? I taught Math 12 so often, I finally did. What's the key to taking this formula and actually applying it to this question? The key is to recognize, well, first of all, what's n? 8. But what's k? Because that's k plus 1 gives me the 7. Oh, what's a? Well, in this case, I kept it simple. A is actually a, but I would feel no problem putting like a 2x or a 3x or something there. And what's b? Again, in this case, I kept it simple. B is, strangely enough, Rosanna, just b. But again, I would have no problem putting something there. So it's going to be, now it's plug and chug. It's complicated plug and chug, absolutely. But be careful step by step, and it is basically substitution. It's going to be 8, choose 6. Yes? A to the 2, B to the 6th. Now, if I had numbers there and there, I'd have to put the exponents onto those numbers. I don't, so this is going to be a little bit easier as it turns out. It's going to be whatever the heck 8 choose 6 is. 8 choose 6. Mr. Dueck, try that again. 6. 28. And then there's going to be an a squared, b to the 6th. See. Okay. Open-ended. Again, I think the written section is going to roughly follow the order that I've taught you. I'm willing to bet on your test, the written section, the first question is going to be fundamental counting principle. Our strategies there were drawing a blank and the Scrabble bag or the grab bag. I bet you the next written question is going to be some kind of a permutation arrangement, maybe with repetition, maybe not. Then I bet you there's going to be a couple of questions involving choose, where order doesn't matter. Then there's going to be probably a couple of questions involving the binomial expansion theorem. And then the last question on your test is the nasty. It's going to be, hey, here's something with restrictions and be clever. It's going to be kind of a combination thingy. Sorry, not a combination choose. It's going to be a smorgasbord. I can't use the math word. It's going to be some more than one. Anyways, I used the wrong word because now you're all going to think it's a choose question. I don't think it is. We're doing 4-digit odd numbers, so this has to be odd. And Brooke, I find for these ones, when they give me a group of numbers to pick from, I just kind of 1, 2, 3, 5, 7, 8. I randomly put them in my Scrabble bag as my visualization. Now, there is a restriction. The last number has to be odd, because that's how I make an odd number. And even though that appears last, I always do any weird restriction or condition first. So, how many choices do I have for that odd number? 1, 2, 3, 4. Got to end in an odd number for it to be odd. Now, once I've put an odd number there, am I allowed to reuse it in example A, or do I keep it out of the bag? So it goes back in, we shake everything up. Now there's no longer any restrictions. Now I think it's going to be 1, 2, 3, 4, 6, 6, and 6. Right? It's going to be 6 to the third times 4 is the shortest way to type that. It's going to be 864. 1 mark. What if I'm not allowed repetition? It's going to be almost the same approach. I'm going to say to myself, I have 4 odd numbers, but now I've used one of them up. Maybe the 5. That's why I draw the Scrabble bag, so I can cross stuff off along the way, and it's easier to keep track. Now how many choices for the first digit? Well, now you only got 5 left. I used up the 3. Now you only got 4 left. I used up the 8. Now you only got 3 left. Okay, so it's going to be 5 times 4 times 3 times 2. 5 times 4 times 3 times 4. 5 times 4 is 20 times 3 is it's going to be 20 times 12. 240? If you find question 2 tough, you're not alone. This is what my Math 12s also found very tough. There is going to be one of these on the written section of your test. It's either going to be a something choose something or a something p something, and it's going to be a factorial equation that you need to solve. How do we solve this? The first thing I would do is I would actually write out the definition of choose. Sorry, not p, Mr. Dueck. NCR is n factorial over r factorial n minus r factorial. That's on your formula sheet, right from that yellow sheet. Okay, so this is going to be n minus 2 factorial all over 2 factorial n minus 2 factorial equals 66. By the way, what is 2 factorial if I actually evaluate it? So I'm going to drop the exclamation point on my next line. It's not that it magically vanished. It's I actually did evaluate it. Hang on, did I write this down wrong, Mr. Dueck? I might have. I did, Mr. Dueck. Thank you. It's going to be n minus 2 minus 2 factorial. That better? Something was twigging me because I was going, everything's canceling. That's yucky. Right? That's better. Now what? I'm going to take this 2 and I'm going to multiply it over to that side. Because dividing by 2 on the left, same as timesing by 2 on the right. When I do that, I'm going to get 132. And I'm going to get n minus 2 factorial all over n minus 4 factorial. Because n minus 2 is n minus 4 factorial. And I'm going to need more room. Now what? Now I start to simplify the factorials. What I do is I ask myself, which one's bigger, the top or the bottom? What's bigger, n minus 2 or n minus 4? So I'm going to expand n minus 2. I'm going to write that as n minus 2, n minus 3, n minus 4. I'm going to stop there because now I can cancel out the n minus 4 factorial. I can say, woohoo! And what I get is n minus 2, n minus 3 equals 132. Now what? Got to try something. Not going to stop here. Now what? Ellen? See what times n pluses. Not yet. I want to FOIL this out and get rid of brackets. I got to get rid of brackets now. Because to solve a quadratic, I have to make it equal to 0. And right now, it's not equal to 0. It's equal to 132. So my next line is going to be n squared minus 5n plus 6. I FOILed. And I've done it enough times, I did it in my head. You may need to show steps and gather like terms, and that's perfectly fine, but I'm running out of room. What kind of an equation is this? It's a quadratic. You know how I know? It's got a squared. How do I solve a quadratic? Got to make it equal to 0. So I'm going to minus 132 from both sides. When I do that, I'm going to get n squared minus 5n minus whatever 6 take away 132 is negative 126. I'm looking for numbers that multiply to 126 and add to negative 5. I have no idea. So I'm going to get out my calculator and guess. What goes into 126? Well, I know 2 does. Oh, what else goes into 126? 63. And what goes into 63? What numbers go into 63? 9. And you know what? I'm going to take the 126 and I'm going to try dividing by 9. Hey, that gives me a 9 and a what? How far apart are 9 and 14? Would they by chance be 5 apart? I think I can make this work. This is how you factor and solve a quadratic. If you're like, I don't know how it factor. Start with 2s and 3s, but look at your results and see what goes into your results and go try those in the original. I think I can go with an n, an n, a 9, and a 14. Which one's positive? Which one's negative? Positive 9, negative 14. What are my roots? Negative 9, positive 14. Poor Roy's not here, but which one rejects him on the date? Okay. Now, how would I mark this for 4 marks? Well, if I did this right, 1, 2, 3, 4, 5, 6, 7, 8 lines. Half mark for each line. Now, that doesn't mean if you skipped some lines, but if you showed work, if you did it algebraically, you get your marks. Now, if all you did is write down an answer by guess and check, sorry, the answer is only worth 0.5 out of 4. Have I showed you where your quadratic solver is on your graphing calculators? I did? So you can always double check your answer, but I would still expect to see the work. Okay? Number 3, pathway problem. Oh, can I use my multiply factorial method? Is this a regular pathway or an irregular pathway? Irregular, okay. So, I can't rotate my paper 45 degrees, or 90 degrees. You guys can, and you'd probably find it easier. I like to go straight down, but anyways, 1. Oh, and remember, Christina, I put the numbers right on the junctions. 1, 1. I don't move down to the next row until I've gone all the way across. 1. Hey, what's flowing into here? 2, 1. 1. What flows into this junction? 3, 3, 1. 1. What flows into this junction? 4, 4, 1. 1, 5. Ooh. What flows into this junction? Well, a 4, and what's coming from here? Nothing. Oh, what's nothing as a number? This is 4 plus 0, 4. How about this next one? 5, 1. 6. Oh, here, sorry. 5. Ah. How about here? Well, what flows into this? What flows into that? Nothing. What's nothing as a number? 0. What's nothing as a number? 0. 9, 6, 11, 5, 9, 15, 16, 14, 24, 30, 38. So if you got that, you got 2 out of 2. Otherwise, if you did not, go track down your mistake. For each mistake you made, take off a half mark. And I'll make this a bit bigger so you guys can see at the back of the room. Okay. By the way, Kyla, you may notice I go very slow and careful on these because it is so easy to make a math mistake. Now, I'm doing the arithmetic in my head. You don't have to. You can quickly be typing this on your calculator if you're concerned about adding numbers in your head and making a dumb mistake. That's fine. Well, no, I mean, I kind of like you to be able to do it in your head, but I'll live with that. Certainly on a test, I probably would double check my math on my calculator because I'm paranoid about tripping on my brain. I don't want to lose a dumb mark because I was too lazy to go type it in quickly. Okay. So you can expect to see something like this. Turn the page. (22) choose 16. The 17th term of the 23rd row is the 22 choose 16. 22 choose 16. It's probably going to be big. 74,613. Did anybody draw the triangle? Please no, I hope. I've finally broken my students. Number 5. What's the key word in number 5? Well, there's 2 key words. The first one is this. Committee questions are almost always choose. C for committee, C for choose. The only time they're not is if they say, oh, there's a president and a vice president and a secretary, if they somehow suggest that order matters. But generally, we don't care about the order. All we care is, are you on the committee or not on the committee? So, how big is this committee? How many people? 5. Did they break it down into subgroups, or can I just go 18 people choose 5? They got subgroups. If there's subgroups, what's my tool? Bucket. Girls, boys, 10 and 8. The second key word is that there. What does at least 3 mean? List all the cases. So at least 3 means 3 or oh, there's more girls, but it says the committee only has 5 people. So these are my 3 possibilities. What does or mean in this unit? Add. And means multiply, or means add. So if I have 3 girls, it's going to be 2 guys. 10, choose 3, 8, choose 2. And, oh, it's 3 girls and 2 guys, and means multiply. Then I can have 4 girls, 1 guy. 10, choose 4, and 8, choose 1. Or 5 girls, choose no guys. 10, choose 5, and 8, choose 0. You know what? Maybe I can type all this in one line if I'm really, really careful. Let's see. It's going to be 10, choose 3, and 8, choose 2. Or 10, choose 4, and 8, quiet please, choose 1. Or 10, choose 5, and 8, choose none. Is the answer 5,292? If you got that right, 2 out of 2. Otherwise, I would look for this. I'd give you a half mark if I saw that, a half mark if I saw that, a half mark if I saw that, and then a half mark for the answer. But if you got the right answer, I'm good with that. Number 6. Write out the first 4 terms of this expansion here. Okay. How do I do that? What's n? It's going to start out with 9, choose 0, choose 1, choose 2, choose 3. That's A, that's B. It's going to be A to the 9th, 8th, 7th, 6th. B to the none, B to the 1, B to the 2, B to the 3rd, and I'll start out putting plus signs, although some of them may end up with a negative in front of them and become subtract. 9 choose 0 is 1. 2x to the 9th plus 9 choose 1 is 9. 2x to the 8th, negative 3y to the 1 plus 9 choose 2 is 36. 2x to the 7th, negative 3y squared plus 9 choose 3 is 84. 2x to the 6th, negative 3y cubed. That's going to be a 1, a 2 to the 9th, and an x to the 9th. That's going to be a 9, a 2 to the 8th, an x to the 8th, a negative 3 to the 1, a y to the 1. That's going to be a 36, a 2 to the 7th, an x to the 7th, a negative 3 squared, a y squared, plus an 84, a 2 to the 6th, an x to the 6th, a negative 3 cubed, and a y cubed, because the exponent goes on to everything inside the brackets. Now I think I'm ready to go to my calculator and try and go final answer. Let's see. It's going to be, well, there's a 1 in front. Is the 1 in front of the first term going to make a difference at all? So it's going to be 2 to the 9th, 512 x to the 9th. Then it's going to be 9 times 2 to the 8th times negative 3 to the 1. I guess I don't need to put a to the 1. You okay with me, Jake, so far? The second coefficient is going to be a negative 6912. So instead of putting plus, I'm going to put minus 6912, and then x to the 8th, y to the 1. The third term is going to have a 36 times a 2 to the 7th times a negative 3 squared. It's going to have a positive 41,472. X to the 7th, y squared. And the fourth term is going to have an 84. A 2 to the 6th. Let's try that again, Mr. Dueck. An 84. A 2 to the 6th. A negative 3 to the 3rd. It's going to have a negative 145,152. Negative 145,152 x to the 6th y cubed. How many terms are there? How many terms are there? 4. How many marks ought to make this worth? How about a half mark for each term? So I would say give yourself a half mark, half mark, half mark, half mark. Turn the page. Rosanna is a disc jockey, although she's been late for work, so they're thinking about canning her. She has chosen 10 songs to play for a school dance. She creates one 10-song compact disc for these songs. How many different ways can she arrange all of them? 10 factorial, which is 3628800. Rosanna, however, realizes that the first 3 songs of the first CD are important in setting the tone. She chooses those 3 songs from the original 10. Math is wonderful. Oh. The never-ending algebra problem. Oh. And you plus me equals us. Oh, what great taste Rosanna has. How many ways can those 3 songs, just those 3 songs? 6 different ways. But now what if we attach the rest? Okay, so how many ways can she burn the compact disc if these 3 songs must be at the start of the CD? So what we have then is this. Three songs, and then 1, 2, 3, 4, 5, 6, 7 blanks. How many ways are there to mix up those 7 blanks? 7 factorial. How many ways are there to mix up those 3 songs? 3 factorial. So she has 3 songs in the front and 7 songs afterwards. 30,240. Okay. Can you give yourself a score, please, at the top of this quiz out of, holy smokes, 27? Hey, we are finished the unit. Put that away. So what's your homework? Well, for the remainder of this class and all of Monday, I'm not going to be giving you anything new on Monday, you can work on this humongous combinatorics review that I gave you guys the other day. This is about a 2-hour assignment, but if you plow your way through this, you will not find a single surprise on the test. You will have seen every question, different numbers, but you'll have seen every type of question. Okay? I have an answer key online. And I'm also going to print up, let's say, 4 answer keys right now, and you can share them, but don't hog them. An answer key showing all my steps.